Hello students, I am Professor NAVNEET KAUR, EC Department, Sagar Institute of Research and Technology, Bhopal. Today I will be taking lecture on topic digital communication. The topic of my lecture is bipolar encoding techniques. Bipolar encoding technique is a type of line encoding method. Now, what is line encoding? We have already done in the previous lecture that the information must be encoded into signals before it is transported across communication media. So data is encoded into form of bits to send them from one place to another. So line encoding method is the method of converting a digital data into the digital signal. In general form, we have taken conversion methods which are of four types. First is digital to digital conversion, which is our line encoding method. Then second is analog to digital method, which is general A to D conversion. Then digital to analog conversion, which is a type of digital modulation technique. And then analog to analog conversion, which is analog modulation techniques. Now, in this lecture, we will be considering digital to digital conversion, which is also called line encoding method. Line encoding method is of three types. In my previous lecture, I have already discussed unipolar and polar type of line encoding method. Now, in this lecture, I'll discuss the third type of line encoding method, which is bipolar encoding technique. Now, as I have discussed, in digital to digital encoding, the digital data is converted into digital signal. Digital signal means that the bits 0 and 1 are represented in the form of pulses. Now, considering digital to digital encoding, I have already told that it is of three types: unipolar, polar, and bipolar. Unipolar and polar are already discussed in my previous lecture. Now, in this lecture, I'll be taking bipolar encoding in detail. Now, what is bipolar encoding? Bipolar encoding, like return to zero encoding, it uses three voltage levels: positive, negative, and zero. Now, in return to zero, the zero level is used to represent either bit 1 or 0. Because in half of the bit, there is a transition from high to 0 or low to 0. Whereas in bipolar encoding, the 0 level is used to represent binary 0. The ones are represented by alternating positive and negative voltage. This means that if the first one bit is represented by the positive voltage level, the second one will be represented by the negative voltage level. And the third one will be represented by the positive voltage level, and so on. This bit alteration occurs even when the 1 bits are not consecutive. Now, there are three types of bipolar encoding. First is AMI, which is alternate mark inversion. Then B8ZS, binary 8-0 substitution. And HDB3, which is high density bipolar 3. Now, this is shown in the form of a flow diagram also. First is AMI, then B8ZS, and then HDB3. Now, first we will discuss about bipolar alternate mark inversion. Now, as the name says, alternate mark inversion, here the word mark comes from telegraphy and it is used to represent high level, which is 1. So AMI means alternate 1 inversion. Here the 0 voltage is represented as binary 0, whereas binary 1 is represented by alternating positive and negative voltages. Now we can see this in an example which is shown in this waveform. Here we can see that 0 bit is represented by 0 voltage level, whereas 1 bit, first 1 bit is represented by positive voltage level, But the second one bit is represented by the negative voltage level. That is, there is an inversion. Because the previous one is represented by positive level, the next one will be represented by the negative level. Now again, if the one comes, it will again invert it and it will be represented by the positive voltage level. Then the next one will be represented by the negative voltage level. So there is alternate mark inversion. That means there is alternate one inversion. Now, a variation of bipolar AMI also exists, which is called Cedaw Ternary, in which binary zero alternates between positive and negative voltages, whereas bit 1 is represented by zero voltage level. Now, the advantage of using alternate mark inversion is that here the DC component is zero because both the voltage level positive and negative is used. And the second advantage that here a long sequence of ones stays synchronized because there is alternation of positive and negative voltage. But the disadvantage is that there is no mechanism to ensure the synchronization of long strings of zeros because here the binary zero is represented by zero voltage level. In bipolar AMI encoding, we uses three voltage level positive, zero and negative. Whereas in Cedaw Ternary AMI, we also uses three voltage level positive, zero and negative, but alternate positive and negative is used in case of zero and one is represented by the zero voltage level. And this type of encoding method is used in DS1 and E1 lines. Here we can see the comparison of AMI and Cedaw Ternary. In AMI, 0 is represented by 0 voltage level and 1 is represented by alternate positive and negative voltage. Whereas in Cedaw Ternary, the inverse of this exists. The 1 is represented by the 0 voltage level and 0 is represented by the alternate positive and negative voltages. Now, these two variations of bipolar AMI have been developed to solve the problem of long sequence of ones. But for long sequence of zeros, the problem of synchronize still exists. So to avoid the synchronization problem in long sequence of zeros, the two methods in bipolar AMI are used, which are bipolar 8-0 substitution and high density bipolar 3. Bipolar 8-0 substitution, which is also called B8ZS, it is first used in North America, whereas HDB3, which is high density bipolar 3, is used in Europe and Japan. Both are the adaptations of bipolar AMI that modify the original pattern only in the case of multiple consecutive zeros. Now first, we will discuss bipolar 8-0 substitution. Now, as I already told, it is used to provide synchronization of long string of zeros. Now, when we consider 8 consecutive zeros, they are replaced by the sequence 000V, B0VB, where V is the sequence which denotes violation. That is, non-zero voltage that breaks the AMI rule of encoding. And B in the sequence denotes bipolar, which means a non-zero level voltage in accordance with the AMI rule. Here we will consider the two cases with the help of waveforms. Now here we can see that we have 1, then 8 consecutive zeros. So 1 is represented by high voltage level. Now 0, 0, 0. So 0, 0, 0 will be represented by 0 voltage level. Now, according to the pattern, after 3 zeros, we have V. V means violation. Violation means that if AMI pattern is used, then the next one should be represented by negative voltage level because the previous one was represented by positive voltage level. But in the pattern, since violation is used, we will take 0, 0, 0, V. V means violation. Since the previous one was represented by high voltage level, violation bit will also be represented by the high voltage level. That means it is violating the AMI pattern. Now, then we have pattern B0VB. B means bipolar pulse. That means if it was originally positive voltage, bipolar alternation will create negative voltage. Then 0 will be represented by 0 voltage level. Then V means violation. So because the previous was negative voltage level, violation bit will also constitute negative voltage level. Then B means bipolar alternation. So it will give positive voltage level. Now, we will consider a second case when the previous level is negative. That means 1 is represented by negative voltage level. Again, the same pattern will be used for 8 consecutive zeros, 000V, B0VB. So 3 zeros will be represented by 0 voltage level. V means violation. So since the previous bit was negative voltage, violation bit will be also negative voltage. B will be the bipolar alternation, so it will be opposite of the negative voltage, which will be the positive voltage. Then 0 by 0 voltage level. Then again violation. Since the previous was positive voltage level, violation bit will also be positive voltage level. And then we have bipolar alternation, which will be opposite to the previous voltage level, which was positive. So it will be now negative voltage level. Now here we can see in the form of slots where each slot represents 1 bit. So here we have positive 8 consecutive voltage level. So 000V where V is violation. Then B0VB where B is alternation and V is the violation. Since this is negative, violation will also be negative. Similarly, when the previous bit was negative, then 000V violation will create again the same negative level, then B0VB. Now, here we will consider one example where we will encode the bit stream 1 8 zeros 00100 using B8ZS encoding technique. Now, here we will assume that the polarity of first one is positive. Now, here first one is positive. Now, since we are having 8 consecutive zeros, we will use pattern 000V, B0VB. So 000V, we will consider positive pulse because the previous pulse was also positive. Then B will be negative, then 0. Again, V violation means since the previous was negative, violation bit will also be negative, then B will be positive. Now we will have 2 more zeros. These 2 zeros will be represented by 0 voltage level. Then comes 1. 1 will follow alternate bit inversion. Since the previous was positive, this will be negative. Then 2 zeros which will be represented by 0 voltage level. Now high density bipolar 3. Now in high density bipolar 3, the pattern changes whenever there are 4 zeros in succession. So here the 4 consecutive 0 voltage levels are replaced with the sequence of 000V or B00V depending on the case when the last substitution is made. So here we have 2 rules. If the number of non-zero pulses after the last substitution is odd, the substitution pattern will be 000V, which makes the total number of non-zero pulses even. Whereas if the number of non-zero pulses after the last substitution is even, the pattern will be B00V, which makes the total number of non-zero pulses even. So if the number of non-zero pulses after the last substitution odd, we will use the pattern 000V. And if the number of non-zero pulses after the last substitution is even, we will use the pattern B00V. Now we will see with the help of an example. Now here we will consider if the number of ones since the last substitution is odd. We know that the pattern used will be 000V. Now since this is positive, 000V means violation. So since the previous was positive, violation bit will also be positive. And if we would have been having negative voltage, then violation will also be negative. Now in second case, if the number of ones since the last substitution is even, we will use the pattern B00V. So B will have bipolar alternation. Since this is positive, this will be negative. 00V means violation. Since the previous was negative, violation will also be negative. Similarly here also, since the first bit is negative, B will be positive, and 00V, V will be positive because it will violate the AMI rule. Now here we will consider an example. We have bit pattern 11, then 4 zeros. Since we will consider that the last after the last substitution, there are 2 ones. That means there are even number of ones. So the pattern will be used B00V. So B will be positive since the previous was negative. Then 00 will be positive voltage. Then 00 will be 0 voltage, and V will be violation, which will be again positive. Then comes 1. 1 will be negative because the previous was positive. Now here after the last substitution, the number of ones are odd. Now the next pattern used for 4 consecutive zeros will be 000V. So 000 will be substituted by 0 voltage level, and V will be represented by violation, which will be negative voltage level because the previous level was negative. Then again 4 consecutive zeros will be there. Since after the last substitution, there are 0 number of ones, which will be considered as even number of ones. So we will use the pattern B00V. So B will be considered as positive voltage level. 00V violation will be again positive voltage level. Now here we will consider one more example. Using HDB3, we will encode the bit stream 1, then 8 zeros, 001, 00. And we will assume that the number of ones so far is odd and the first one is positive. Now, first one is positive. Since the number of ones, since the last substitution is odd, we will use the pattern 000V for 4 consecutive zeros. So 000V violation, which will be positive voltage level. Then again for next 4 zeros, we will use the pattern for even, which will be B00V. B will be negative. 00 violation will be again negative. Then we have 2 more zeros, which will be represented by 0 voltage level. One will be, we follow the AMI rule, which will be alternation. Since the previous was negative voltage level, this will be positive voltage level. And then again, we have 2 zeros, which will be represented by 0 voltage level. Now here we can have combined look at bipolar AMI, B8ZS and HDB3. In bipolar AMI, we can see ones are represented by alternate positive and voltage level, 0 volt, or positive and negative voltage level, but zeros are represented by 0 voltage level. Whereas in B8ZS, for 8 consecutive zeros, we have used the pattern 000V, B0VB. And in HDB3, we have used bit pattern for 4 consecutive zeros. If the odd number of ones are used since last substitution, we have used the pattern 000V. Then again for next 4 zeros, we have B00V. Then we have 2 ones. So since the number of ones are even after the last substitution, the pattern used will be again B00V for the next 4 zeros. Now this is all for today's lecture. Thank you.